Hello everyone, my name is Zijian Ding, the presenter of today's poster. Our topic is effects of loop detector position on the microscopic fundamental diagram. The collaborators include Kayong Li and Dr. Lava from Georgia Tech. The purpose of our research is to investigate two distinguished MFD bias induced by the loop detectors. The first bias, we call it LD bias. It represents the bias between the link MFD and the loop detector MFD. And the second bias is subset bias. It refers to the bias between position-based subset or loop detector MFD. After that, we will use three different methods to investigate the effect of these two MFD bias: the analytical methods, empirical data analysis, and the traffic simulation. For the analytical methods, we assume a homogeneous corridor that orbits a symmetric triangular fundamental diagram, and we assume three different types of time-space diagrams on the saturated condition. The first case is there are no waveform at the intersection, and the second case is that the traffic jam will happen at the intersection, but they are finite void, which means the all state will terminate at the intersection. And the third case is in the third case, the traffic jam will also happen at the intersection, but they are infinite voids, which means the all state will extend at the consecutive intersections. For the empirical data analysis part, firstly, we use UT19 dataset to show the existence of LD bias and subset bias in the empirical data. After that, we use the logistical regression to find variables will help explain the subset bias. From the regression outcome, we find that the mean value and the standard deviation value or relative position, these two variables are related to the subset bias. For the traffic simulation, we run a network traffic simulation in Sumo to investigate the effect of network parameters lambda on the subset bias. We find that as the lambda increases, the maximum average traffic flow will increases, and the lambda increase will help generate a smaller subset bias. To conclude, our research mainly focuses on investigating the MFD bias induced by the loop detectors, and it will help open the possibility of method to correct this loop detector MFD bias in the future. Thanks everyone. So.